The first category that we'll deal with today is fashion and jewelry. And these are some of the examples that we would try to emulate in the BeeGraphy workspace. The second category we'll deal today is furniture and home furnishing. This would be closer to how do you make your furniture models or home furnishings very parametric, in the sense that you don't really have to go to the script. You can always modify everything in the configurator mode. This would make it much closer to what BIM ecosystem does. Then the third category is education. Here we'll deal with a certain aspect of education where it makes it much easier for students to understand uh, large scale concepts which are quite difficult to understand. So this can easily help us through the platform of BeeGraphy. So I'll start with the first category that we have today, which is fashion. Um, this category, sorry. Yeah. So this category, the intent of this particular section of the workshop, 3A, is first we'll have the workshop intent, then we'll try to understand the existing references, and then we'll try to build a design logic, and then we'll explore the design on BeeGraphy, and we'll try to import some materials, and then the challenge. So the brief of the challenge that is provided on the Uni XYZ platform is this particular section would be for fashion designers, jewelry designers, textile engineers, tech enthusiasts, and it's related to style and innovation in fashion and accessories. Um, it wants to get out timeless aesthetics, creating wearable pieces, but with function and fashion. So at the same time, it needs to harness the capabilities of BeeGraphy as a platform. And how do you incorporate parametric design into your fashion pieces? It needs to be form, functional, and wearable. It can be influenced from the current trends of smart clothing, environmentally friendly clothing. It could be 3D printed jewelry or intricate details in your textile itself. So it could be any of these. And it can be also influenced from traditional fashion or the future. So it's a wide scope, and then it would be a good healthy playground for anyone to get involved in. So these are some of the examples we have available online. Like the piece of clothing that you see is all 3D printed. In these images, one is a carry bag, and the other one is a decorative piece over the shoulders. Then these are some of the other examples that could be done through BeeGraphy or through parametric softwares. You have parts that go around the body, neck, or the arms, and then we have large cape, and then we have dresses that flow throughout their body, but in a more organic fashion. We can also get influenced from remapping tools in BeeGraphy and can create forms which follow the contour of the body. At the same time, they become larger or smaller. They react to the contour of the body. And we can also look at jewelry through the same lens. So there are some examples of parametric jewelry. Um, it could be earpieces, it could be necklaces, and based on tween curve functions or based on rotation and lofting. So there are multiple ways in which BeeGraphy can help you make these. The first step for fashion would, of course, be getting the sizing perfect. So we would have to go hands-on, get the widths, get the dimensions of the host, and then we can try making a form in BeeGraphy, or we can just get basic dimensions of the subject, and then we can do through that. So today, what we'll try to do is we'll try to get a mix of all of these reference images and try to understand how we can do that in BeeGraphy. So I'll just jump to the BeeGraphy workspace. Also, I'll just try to remind the previous workshops are available online on the BeeGraphy's page. as you can see here, as well as there are multiple other workshops which can always help you refine your skills in this domain. So as we enter the BeeGraphy workspace, I have already created a file, but if you would want, you can always create a new file. And then it could also be shared through this window. So we have a configurator, viewer, and then we have a share mode. So you can have access to multiple parties involved in the design. So I'll just open the file. So for this particular workshop, I have a mannequin already prepared. How I did it was I imported an SVG file. I'll just show. Yeah. So I'll just explain the logic behind the mannequin. It's basically a series of lofts that you can do. It could change as per the measurements that you are taking of the subject. It could vary as it goes up. You could also incorporate the arms. And once you loft through all of these, you would be able to generate a mannequin. We can also provide you one base. And after we have generated a mannequin of a body, or it could be of a hand, for a arm, for an armlet, or we could have it for a necklace. So all of these could be generated before we start onto onto designing our wearable. So how I did this was I just got in some reference curves which were based on the sizing of different parts of the body, wherever the contour of the body was changing, and then these were put to scale and then moved to a certain height. So so for instance, I got the SVG file in a two-dimensional fashion, and then I moved it up, moved them up to their individual locations, and then I just lofted them to generate the final form. So I won't waste more time on the base of it. It would depend on your subject. I'll just go on directly to the variable part. So once we have the mannequin ready, and this mannequin is located on the grid 00 point of the BeeGraphy workspace, the first thing I will want to do is make the base curves of the dress that I'm trying to build here. So for that, we can use the curve editor tool. If I write curve editor, this is the tool that we have. Uh, just for the explanation purpose, I'll just switch off the mannequin and I'll try to work with the curve editor tool. So as you can see, the curve editor tool is in the positive direction. This would be based on the width and height that is given here. And as we go down, we can see there are like 4 parameters here. These are basically 4 of these control points that we see. So I will also switch on the grid so that we can understand visually how big the geometry would be. So now I would have to what I want to do is develop like a outer line for the clothing, which I would then loft across so that I can develop a dress around it. So for doing that, I'll try to create that form of the clothing. So the first thing I'll do is I'll try to get a base point for the center. So base point for this particular curve editor window is somewhere here. It's a 18 by 9 grid, which is based on this 420 by 225. So if I take one of these control points to say the middle of this grid, it would come somewhere here, which is 200, 210 and 1110. So that would be my base point from where I would move this geometry and take it up to the mannequin. So I'll construct a point and I'll give it the x and y based on these dimensions. So I'll make it 210 and 110. I'll put this in the x, I'll put this in the y, and you can see it's somewhere there where this point is right now. So the next thing I would want to do is find out where my starting point is. So one of these would be my starting point, which is coming this one. So I can keep it at this point, and then I'll try to develop a geometry around. So I want it to be a closed curve. So I'll click on this tab here and I make it closed. So now I have a loop, and now I can modify these points. I would want the starting point to be at this location only. So I will double click on the curve at any point so that I can have more points in the space. So I'll just develop like a basic geometry for now. So as you can see, we have a basic geometry. It's centered around, I'll just move this a bit aside. Yeah. So you can see we have our base point and we have a curve, which is based here. Now we would want to, I'll just switch on the mannequin. So we would want this curve to be located somewhere around the somewhere around the chest area of the mannequin. So somewhere here. So I'll just move this curve first here, and then I'll move it up. So for doing that, I will just use vector to point this one. So we would want to move the geometry from the base point, which is here, to the 0, 0, uh, 0, 0 grid point. So construct point, and this would be our second point. So we now have developed a vector which goes from here to here. Now what I will do, I'll just move this ahead. Now I will move this curve to that point, and you can see it has moved to that point. And now I'll move it up. So move again in the Z direction. So this would be around, say, 700. So I'll just write 700. Oh, so I think the scale of the curve is a bit small, so we would have to increase the scale. I'll put it as 1.5 scale. I can do that after moving it, and or we can, yeah, I think I'll do it after moving it. We would have to give it a centroid, so we can get that from the geometry itself. And I'll put it. Oh wait, I think we need to do the thing before we move it, because we already have a base point in place. And if I go back, the center point we can take from the base point we made, and the scaling I'll make as a range. So 1.5 range input. This would be scale first curve. And then I think I will move the geometry. So I'll move it ahead. Yeah. So now you can see the geometry is somewhere there. I will switch off the previous parts, and we'll just try to modify this geometry based on the outline of the body there. So we can easily move any of these curves now to fit onto the mannequin. I can introduce more points. There are two ways to introduce more points. You can either double click on one part and introduce a point. It would be visible here at the base. Or if you want, you can, if you want to be very precise and you want to introduce a point between two of these, then you can check this is this point and this is that point, and then we can come here and we can add a new point. So then this point could be taken a bit ahead. I'll move this a bit back. And we'll do the same thing between these points. So I'll add a point here and I'll move it a bit ahead. And we'll add another point between these two, which would be here. And then this can take the shape of the back.
Divya, I can show you a trick. When you click on the points,
Yeah.
you can see the white control points. If you click
Yeah.
on one of those, double click, it will add a point there.
Yeah. So even that way we can do that. Um, Thanks, Learnick.
Yeah, you're welcome.
Corporate. Yeah. Uh, so I mean, yeah, we just have to get the contouring of the body right, so that it can help us make some of the form. So I have a base form ready. Can make it a bit more symmetric. And the amazing thing is that you can always modify the shape later on. So I have one of the curves ready. The next curve I would want to develop is somewhere around the base. So I don't have to redo the whole thing. I will just be copying this. I will also introduce you to a node. So if I double click on one of these wires, we'll have this node popping up, and this is basically just carrying the data from here, and this could be then put into in place of directly connecting it from the main output. So if I put it here, you can see uh, I can use it like that. uh, so now if I have to develop more curves, I can just copy this whole set multiple times. Um, I will develop this. If I decrease the height to 500, you can see the curve now is at the base, and I can now reduce down the points to uh, fit to the waist. Again, I won't be very perfect here, but I think this gives you the possibilities, the scale of possibilities that we have. We can also repeat the process again for the hip area. So I'll just duplicate this by pressing Alt, and then I'll reduce down this to 300. So I think it's inside. So I will either scale this up a bit and then give it some slight variation based on the shape there. Yeah. The next thing we can do is for the lowermost part. So I'll copy one more time. And this time I will try to rotate the base. I'll take this down to 0. My mannequin actually starts at the grid point, so it's supposed to go up, but it could change as per your subject. So if I'm just doing something for the top, if I'm doing something for the lower part as well, then I'll raise the mannequin and introduce the legs as well. So in this case I don't require so now I have, okay, I think this is too wide, so I'll just reduce down this a bit. Yeah. And then I'll try to rotate the bottommost curve. So for doing that, what we can do is can go to the lowermost curve. We will write rotate. We can use the rotate axis tool. You just have to provide it the curve, and then you would have to provide the centroid. So centroid can come from either the grid itself or the geometry. So centroid, put in the geometry. I'll put this into the center. Then we would have to give it an axis. So I wanted to rotate on, say, the y-axis, which is this part. So I'll just give it the y-axis, vector y, and this will plug into the vector. And then angle we would have to convert from degree to radians. So the first thing I'll do is that, and then we can give it an angle, which would be a range input. So I'll give it say 0 to 90, and I can double type and write bottom curve angle, and this would go into the degrees. So then I can increase or decrease the angle, and you can see it is reflecting. Sometimes when you're increasing the angle, then you would have to modify the geometry a bit so that it fits the body properly. I'll hide the previous part. Yeah, so I will just modify this geometry a bit, increase it on that side as well as on this side. Yeah. So we have our base curves ready. Now what we would want to do is give some more character to this, dress, because if we directly loft, it would look very flat. Maybe we can try to develop like a chevron pattern, and then maybe we can try to introduce graph mapper into the exercise. So I'll start with the topmost curve here. We have, sorry, it's a bit laggy. Yeah. So we have our topmost curve here. What we can do is maybe we'll divide the curve into points, and we'll take every alternate point in and out. So I will um, divide the curve by count. So I'll put in the geometry here. I will take this a bit ahead because this we can copy again and again. I will increase the count to 50. Sorry, this needs to be a range input. So I'll just write 50 range, and then I will make this as the chevron count. And I'll put this in count. You can see it has developed points for the curve. Now what I can do is I can make two lists out of the points. So I can put every alternate point in a different list. For that, we can use dispatch list, and I'll put the points in. Um, you would have to provide, so currently all the points are going in A, so we would have to provide boolean for that. So I'll just write true ones. So boolean is basically true and false, so it's like 0 in one list, 1 in the second list, and that pattern continues 0 and 1 continuously. So I'll put two of these. One would be false and one would be true. And if I switch off, um, yeah, so you can see it's 25. I would have to switch off the previous as well. Yeah. So you can see alternate points have been put in list A, and the other list would have the other points. So now what we can do is I'll just preview on one of them, and then I will try to move these points out. And for moving this point out, we would require a vector going in that direction. So maybe that vector we can achieve by the centroid of this shape. So I can just take a center point, and then from the center point, I can have a vector going to this point, and that would give us a direction. So I'll do vector to point again, and then I will introduce a centroid from the curve. So so this is the moved curve. I can again make a node here, and I will use this node for the geometry. So this gives us a center point. Now what we can do is we can make a vector from the point 1 to the point 2, and we have the vector. So now we will just move these points and give them an amplitude. So the vector is there, but we would still have to give it an amplitude, how much distance it has to move. And I'll plug that in. I'll plug this into the vector, and I'll plug this into the geometry because that is the geometry we would want to move. Now, what we can do, we can try graph mapper here. Graph mapper can basically give us quick variations without manually moving each point in a gradient. So if okay, first thing we can do is we can try a simple one. I'll just move these points by a constant of 15. So you can see these points have been moved out. And then what we would have to do, we have the other set of points as well. These ones, and we would want to develop like a polyline going from one list to the other. So first we would have to do is weave these two lists together. So the first one I will do is this, and then the second one I will do is this. But it is asking for a number. Number is basically a boolean. Sorry, it's we would have to give 1 and 2. So it asks for a pattern here basically. So I will just write 1 and 2, and I can just give it both of these numbers. This is our pattern. So what it will do is it will weave from the first list first, and then it will weave from the second, and then this thing continues for the whole list. So now again we have 50 points with us that we can interpolate. So I will use a polyline, uh, this one, and then we can plug this in. And boolean requests you if this needs to be closed or not. So I will write a true for that. If I write true, I'll get the boolean, and I'll put this in here. Now, if I switch off the whole of the previous part, you can see we have an interesting in chevron pattern to the curve. Now, what I wanted to try with the graph mapper was that maybe we don't want this to be a constant distance from the base curve. Maybe we want it to go in a gradient. So instead of this 15 here, which is a constant, we can try remapping based on the number of points we have. So if I open graph mapper, you can see there is a base where the graph would be located. So I can select multiple graphs. Maybe I'll go with a sign. Um, and the domain for this graph is 0 to 1 and 0 to 1 and 0 to 1. So it basically graph is only this purple thing that you see here. It's only restricted to that right now. And the domain is only going from 0 here to 1, 0 here to 1. So but we want it to reflect here, like this smooth result. We want it to reflect here. For that, we would have to give it the number of points we want to move out. So if I go back, I can first analyze what my list length would be. So if I get the input from here, I can see that my list length is 25, and I can base my graph on this list count. The next thing I would want to do is I would make a range from it, which would go from 0 to 1 only, because our domain is 0 to 1, but it would divide the domain into 25 equal partitions, so that those would then give us results based on this graph. So I'll make a range. I think it's called list sequence, and this length would go into count. Our start and end would be 0 and 1. So I would have to provide it a 1 here. And then this list would go into X. If I show you what the list has, it has 25 values ranging from 0 to 25, 0 to 24, and then it has equally divided between 0 to 24. So now we have this pattern with us, basically, and then what we can do is then remap this pattern onto our distance from the base curve. So this source is going from 0 to 1. So the remapping thing would also go from 0 to 1. The numbers that we would have to provide it as these, which is the output of the graph mapper. And the source would be 0 to 1. So we would have to again provide a domain which goes from 0 to 1, because these numbers are going from 0 to 1. And then our target domain would be how in or out we want it to go. So maybe I wanted to start from 5 millimeters outside the base curve, and then I wanted to go to, say, 30. Oh, actually, we can make these range outputs. So 5 range, say, minimum distance and maximum distance. So this would go into our target. So now if I put this here instead of the number constant, you can see it has already mapped it, where it starts slowly increasing the distance as it goes till the end of the curve. So this could be an interesting twist to a simple pattern. I'll move this ahead. We can also change. Yeah, sorry. We can also change the curve. So if I go for a purlin, you can see it is not as variable, but I can increase the size to increase the variation. Oh, it's too small. Yeah. or we can go with parabola. So you can see there's like quite a lot of variation now. We can always play with how much variation we want. I don't want it to be too strong, so we can just go with a simple geometry. Yeah. So as you can see, now it looks good. We just have to copy the same pattern to all of the curves that we have. So that's why I made a note there. So I will just move this part, move this part a bit ahead, along with the node, and then I will just copy this whole geometry 4 times. So I'll put this in to the node. It can be a bit laggy if there are a lot of polylines involved. Yeah, so you can see it has been replicated there. Then I'll do the same thing again for the next one and the next one. Yeah, so I'll move this here. Sorry. Yeah, once you see that hand symbol, then it has detected the node. Same with this one. Great. So now we have a variation in all of them. What we can do now is just loft all of these together. So I'll introduce a loft surface component, and then I'll also introduce a list merge. This is basically merging all of these different curves, but in a sequence. So this is our first one. So I'll start with that. I'll take this up a bit. I'll put this in. And then if I go to the list, I can add a point. I'll move this down, plug this in. Sorry, it's a bit laggy. Sorry, I did not introduce a point, so I'll add a point, and then I will add the third one. And then same thing I'll do for the last. First add a point, and then I will add last one. So now I can put this sequential list into the loft surface component. I'll zoom in. Then I'll put this. I'll just check if the list is in a single branch. It looks like it's a single branch. So I'll plug this in. I can increase the degrees to 3. Yeah. Looks like the dress is still not it's intersecting with the mannequin, so we would have to modify one of the curves. Maybe we can try modifying the middle one a bit so that it fits. So you can clearly see the parametric nature of the script. So maybe I can increase the size a bit here as well as here. I can also add more points. I can also add more points. I can also add. It looks flat now. Yeah. So just yeah. So you can see how easily we can modify each of these curves, and we can also change the height if we want to increase or decrease the size of the dress. Maybe I want this to go a bit lower, so I can go down to the last one and change the height from 0 to -50 or more, maybe -500. So you can see we can take the dress much lower if required. Yeah. Then what we can do, we can also try importing textures to it. So for doing that, we can use an online library. So if I write texture, apply material, I'll just go material. Yeah. So geometry we want to apply is this. Now we can give it a texture string. Um, Let me just show just a second. I'll just stop sharing. Yeah. Um, yeah. So for giving a texture to the dress, what we can do is we can give a string output here. So if I write text, uh, uh, sorry, text input. So if I write input, we have it here, and then the string we can provide. So we can provide the string from the Polyhaven website. So if you go to Polyhaven website, you can go to their textures, which you can find polyhaven.com/textures, and then here we can go with a fabric texture. So you have multiple of these, preferably which are like slightly older. So if I go into the fabric pattern here, I can use this one. So I can just the uh, copy the texture URL, the name of the texture, and I can put it as an input file in the text input parameter, and I can put this in texture. So it can take some time, but then you can see it reflect. I would have to switch off the previous paths. I would have to decrease the metallicity to 0, roughness to maybe 1. Hmm.
In fact, this
Yeah,
was experimental.
yeah.
Have you tried this particular pattern? Because not all
No,
the
not
patterns,
yeah, yeah, yeah. No, I'll try a
uh,
different one. Maybe we can go with
especially
denim. Yeah. So I'll try denim first. Yeah, you can see it has taken the denim's color and the texturing. So this can help us give a good gradient um, for the dress. So if now I can maybe try to develop, so in the same way that we have developed this, we can also develop a necklace for the object. But I think I will like to uh, stop here because we have two more workshops, and if there are any questions related to the whole process, I'll be happy to um, take them.
I think you can explain about the material part because right now it works only with polyheaven, right? And some of the older texture, which Lernik mentioned in the Discord.
Yeah. Yeah. So currently, it is based on only the polyheaven, but there are other things that are being tested. So what these textures, the ones that are older than 2 years, would work better. They would give the correct results. So if you go down, you can, as per your requirement, you can go and check what year it is written on the texture. So for instance, brown leather is 4 years. So I can then just select this and use it as our texture in text input.
Is that?
Yeah, so you can see it has taken the texture color. So it would work mostly with the textures that are 2 years older. Some of them are 4 years, so that would be fine. The newer ones are still in beta testing, so would be available later. Yeah.
Divya, if you rotate to the back of the model,
Yeah,
like it's flat there, or
this one.
yeah,
It's because it's because of the curve. So it can take some time getting the geometry of the mannequin right, like geometry of the curves right. So
Mhm.
each one can do it individually. So this is like the third one. So if I go and modify,
If you can modify the last one, I think the rear side of the
yeah, no, if I can just modify, say, this part, then you can see it will modify accordingly. Uh, yeah. So I mean, the you can increase the number of these lofts to as many as possible based on wherever the geometry is changing. So I can maybe introduce one here, like one more, and then it could be more closer to the mannequin that we have. So it will make it easier for us to design. So yeah. So I mean, all of this is parametric, so it could easily be modified. Yeah. So should we take like a
5 minute break or
two
10?
minute 2 minute 3 minute break, and then we can start with the next.
Maybe we have a question. We can
There's a
take it
question.
before the break.
Hello. Sorry, I have a question.
Yeah, yeah.
I was wondering why you were creating curves instead of just using a plane and make an intersection to have I mean, to have the outline of your model.
Yeah.
Is there a way to do that, or you have to do your curves? You have to do. I mean, you have to manipulate your own curves.
No, that's a perfect point. You can do that as well. So what you can do is you can develop like a grid and then plane, and then you can take it to the mannequin's level that you want, and then you can generate a curve there. That's perfectly all
Yes.
right. I was just trying to make people understand the curve editor tool. So
Okay.
yeah,
Okay.
yeah, yeah. So
Okay,
yeah,
that makes
definitely
sense
you can
then.
do it
So,
that way as well.
Lorenzo,
Okay,
it
thank
is
you.
required that at least at one point of time we would have to manipulate the curves to meet the actual comfort of the subject or the client. So either you can manipulate the dimension of the mannequin, the base itself, based on the size that you measured, and then doing the dress on top of it easy. The other approach, which is like a more standard approach followed in the fashion world, is that the mannequin is of a standard size and the dress on top of it is manipulated to meet the client's demand. Both of them are completely okay, which suits you better.
Yeah. Any more questions?
I have a comment.
Yeah,
When you were doing this graph mapper, you
yeah.
were remapping numbers to change them from 0 to 1 and then remapping it again. But there was an easy way. I guess you intentionally didn't do it, but I was just curious.
Yeah, sure.
Like you could go and change from 0 to 25 or the
Yeah,
X and Y.
that would be manual, right?
Yeah.
It will
Every
be
time.
one. It is a wonderful thing.
Okay.
Learning. The only thing is it cannot be added with a range input.
Okay.
So it cannot be configured later. It has to be a static input. If it is very rigid, then only we can use that part.
Okay. Yeah. Got
Yeah,
it.
it'll be static. So I just wanted to make it parametric. So whenever you can increase, I want to increase the size of these. I can easily increase, sorry, number of the chevrons. So that would be possible if
And
it is.
what?
Yeah.
Yeah. One more thing. You when you're using number constants,
Yeah.
is it because it's easier for you can type in many ports directly, like change the default value of the port?
Where this one?
Yeah, like if you disconnect the wire.
Yeah, I'll just do. Oh, sorry. Yeah.
You can click on the one. No, right in the port. Yeah, in the top, where the one is. Yep.
Yeah.
Over there.
I think the
Okay.
cursor doesn't point in the right place.
So you
Actually,
can change from there.
Yeah.
In many cases, it's more convenient, unless you need a slider, of course.
Yeah.
I personally prefer to add a number constant. That way, I remember what is the input provided by me and what are the default values that exist in a node.
Okay.
But it is very useful, this thing, because it makes the script a lot more cleaner. Whenever there are standard values, it can be added directly, and we unnecessarily stop the process of adding another thing.
One more trick, which is in Grasshopper. I mean, you're doing it the way which is standard, like in Grasshopper, but in BeeGraphy we thought it would be easier. An easy way to disconnect a wire from the port. In fact, all wires from the port. You don't have to drag all the way. You just click the control or command in your case, since you're on a Mac device.
Yeah.
And then click on the port. You don't have to drag, so you just hold the control and disconnect.
Okay, hold the control. Okay, it works.
Especially when the ports are far from each other, it makes it a lot
Yeah.
easier.
Yeah, that's quite handy.
There's a question from June. I mean, not question, but she wants you to show the material node block.
Yeah.
And how did you apply the texture? So if you can please repeat, probably,
Yeah.
what was the process of applying texture?
Sure.
Before Divya repeats it, I want to add there. So this material thing, it was a temporary solution by our developers, and it didn't mean to be there for 2 years. We did it just to test ourselves how the textures would work, but then eventually never had time to redo it, so it stayed. Hopefully by the end of the year we will make it a way easier. So what we did with textures, with the library of there is a library called Polyhaven that Divya showed.
Yeah, this
So whatever was available back then, 2 years ago in November 2022, we uploaded those textures, and if you use the name of the texture that is available as the last part of the URL of that texture in Polyhaven, it will work. But sometimes there are textures that still won't, even though they're like 3 or 4 years old. So you would have to try whether that texture is there in our database or not. But Divya, maybe you can show it what I said and what you were actually doing.
Yeah. Yeah, it's the same thing. So once you put in the geometry to the apply material node, you can just provide it color as well. But if you want a texture image, then you can use a text input string input. So, and then you can adjust the metallicness or the roughness or the opacity of the objects. I can try that as well. If I put this here, I can reduce the down. Sorry, it needs to be between 0 and 1, so 0.5 maybe. Yeah, so maybe 1. Yeah. So the next thing we would want to do is give a texture input. So if we go to the Polyhaven website, you can go to the textures. You can go to the textures, and then you'll have multiple textures based on the type. So you can,
Divya,
yeah.
you're not sharing the screen, just the tab.
Oh, just the tab. Sorry. Can you see this now?
Uh-huh.
Yeah. So we have the Polyhaven
Wow.
website, and
So
here if you go,
you're now sharing the Polyhaven tab so they can see the URL.
sorry, I will just share the screen. Yeah. So you can go to the Polyhaven website, and then you can go to their textures part of the website, and then you can see there are 543 textures available. Then if you go to, for instance, I want fabric, I can go to fabric category, and then I can choose with the available examples. Now some of these would be quite old, but some of them would be quite new. For instance, this is 10 months old, but the particular component would work better for the ones which are 2 years older or more. So for me, like when I was trying the denim fabric, this was working. So how you would want is you will just open the textures you page, and then you can go to the top to the URL and just select the last part of the URL. And then you go back to BeeGraphy workspace, and then in the text input you can just um, paste the last part of the URL, and you can see it has been mapped here. Think texture mapping. Okay,
UV map.
UV mapping. Yeah. So I mean, this could be changed through UV mapping, but I think that's a longer process as well.
Explanation.
Yeah, explanation as well. So yeah, so this is how you can basically apply textures to your objects.
Okay. Thank
Yeah.
you, Divya.
Sure. Any more questions? Should we take a break, 2-3 minutes, and then we'll start with furniture? Yeah.
Yeah, let's do a 2-minute break in case anybody wants to grab a cup of tea or
Yeah.
get rid of one. One question from me regarding that dress.
Yeah.
Like, how would one manufacture it? Like, you would have to like make it a 2D thing and then export as a curve DXF.
Hmm. Yeah, that would be ideal. If I mean this particular design phase would be used for like presentation purpose, I guess.
Mm-hmm.
And once the presentation part is done, then they would have to think how do they manufacture this. So maybe they would have to develop like a flatter template for it. And most of the fashion industry runs on templates only, so they could easily get templates for each part of the body and then develop the template based on the chevron pattern. So I think even in that, BeeGraphy would be able to help, because once you have the template outline, then maybe they can use BeeGraphy for like parametrically modifying the shape for that particular part of the body, like that particular part of the dress. So even that is like a separate tutorial session. How do you manufacture it?
You can probably unfold the geometry and put it on fabric, cut it, and then fold it again in the same fashion.
Yeah, unfolding can sometimes have.
So I had a laser cutting machine
Yeah.
some time back. So people used to come with these handbags design,
Yeah.
So they have these shape and they will get it laser cut in the leather, small,
Mm.
small part, and then they will fold it again, pack it in the form of bag and ship it. So I think it's just unfolding the surface, the whole geometry, and
Yeah.
then refolding it. It's
Yes, but I mean, what I have understood through experience is that unfold doesn't work most of the time if your geometry is too complicated. Uh, so then you would have to develop a logic behind unfolding also, like how you would want to do it.
Mhm.
Yeah. Then maybe you component first, like unitize the whole thing first, and then each component you unfold,
Yeah.
and then you put them together. So
And there is an interesting concept of packing which
yeah,
is used in Grasshopper, right? So
yeah,
that can be used to fit the all the unfolded geometries in a panel.
yeah.
I think, do we have something like packing coming up in BeeGraphy? The packing mode.
No, it wasn't in the backlog. Honestly, nobody asked for it. Maybe after this workshop, people will start asking for it.